What if I told you there's a sequence built from a simple rule where if you divide any term by its position, you almost never get a whole number. But at a few secret values of n, it lands on exactly 2 every single time. This is problem 1 from INMO 2025, the Indian National Math Olympiad. Here's the question. You're given a sequence starting with A1 equals 2, A2 equals 3, and for every k greater than or equal to 1, the rule is A sub 2k plus 1 equals 2 plus twice A sub k, and A sub 2k plus 2 equals 2 plus A sub k plus A sub k plus 1. The question asks, find all positive integers n such that A sub n divided by n is an integer. Okay, so step 1 of any problem like this? Just compute. Don't think too hard yet. Just crank out terms. A1 is 2. A2 is 3. A3? That's 2 plus 2 times A1, so 2 plus 4, that's 6. A4 is 2 plus A1 plus A2, so 7. A5 is 2 plus 2 times A2, that gives us 8. Keep going. A6 is 11, A7 is 14, A8 is 15. Now, the real game. Divide each term by its position. A1 over 1 is 2. That's a whole number. A2 over 2 is 1.5. Nope. A3 over 3? That's 2. A4 over 4? 1.75. No. A5 over 5? 1.6? No. A6 over 6? Not even close. A5 over 7? Exactly 2. Let's keep checking. A15 over 15? Exactly 2. A31 over 31? 2 again. So our winners are n equals 1, 3, 7, 15, 31. Now look at those numbers. Really look. 1 is 2 minus 1. 3 is 4 minus 1. 7 is 8 minus 1. 15 is 16 minus 1. Every single one is a power of 2, minus 1. So we've spotted the pattern. But here's where the real math begins. I'll give you 2 big clues. Clue 1. Look at the differences between consecutive terms. A2 minus A1 is 1. A3 minus A2 is 3. A4 minus A3 is 1. A5 minus A4 is 1. A6 minus A5 is 3. Notice something? Those differences are only ever 1 or 3, never anything else. And you can prove that using the recurrence. And that tiny fact? It's incredibly powerful. Because if every step is at most 3, then A sub n is less than 3n. So A sub n over n is always less than 3. That means if it's ever a whole number, it can only be 1 or 2. But can it be 1? That would mean A sub n equals n. Here's clue 2. Check the parity. A sub n is even when n is odd, and odd when n is even. So A sub n and n always have opposite parity. They can never be equal. The ratio can only be 2. So now you know, the answer can only be 2, and it only happens at powers of 2 minus 1. You've got the pattern? You've got 2 huge clues. The differences are trapped in 1 and 3, and parity kills half the possibilities. But can you finish the proof? Can you show why it's exactly the powers of 2 minus 1 and nothing else? Try it and follow this channel because we're dropping the full solution soon.